Hi, the regularization can be applied to the logistic regression results whenever our model is overfit with the training data. So overfit is occurred when the model is trying to cover all the data points. That means it is trying to read all the patterns from the given training data. So here there is the possibility of difference between the training accuracy and testing accuracy. There will be much difference between the training accuracy and testing accuracy. So if there is the much difference, that is called high variance. If there is high variance between the testing accuracy and training accuracy, then we can say that the model is overfit with the trained data. So which is happening due to the noise or inaccuracy values of the attributes in the given data set. So here the regularization can be applied to avoid this overfitting. So when can we say this? So once you are applying the logistic regression to predict the output y dash by using the sigmoid of g 1 over 1 plus e power minus g, then you will apply the cost function. So from this cost function you will get the error. So after cost function, you have to apply the gradient descent to optimize your model. After optimizing your model also, right, there is the possibility of getting training error is very less and testing error will be high. So that is the variance. Okay, so if it is the case, we can apply the regularization approach to avoid the overfitting in the model. So here it will try to reduce the magnitude of the values of theta. So where is the theta available? Our g. So here we are using the g. So theta 0 plus theta 1 x1. So here we are overfitting, try to reduce this parameter values to avoid the overfitting. That means to reduce the error in testing model, right? So here we can use either L1 regularization, that is called lasso regression, L2 regularization, that is called ridge regression, or one more approach is earlier stopping, which is limiting the number of iterations by using the learning rate. So here when you are getting the loss function using the binary cross entropy, j of theta equal to minus 1 by m number of samples summation of I equal to 1 to m y log y dash. So this is actual output of the ith sample. This one is the predicted output of the ith sample plus 1 minus y I actual output of ith sample into log of 1 minus predicted output of yth sample. So this is the term we are using here as a regularization term. So we are applying the L1 regularization with the cost function to avoid the overfitting. The lambda is here regularization parameter, which value will be always 0.1 or 0.01 like that, and summation of j equal to 1 to n, number of features. N is number of features, because here if we have g equal to theta 0 plus theta 1 and x1, we have to update theta 0 and also theta 1. So here our j value is 0 to 1. Okay, so this one and this one. So here we are going to apply this cardinality of theta j power 1. Okay, theta j power 1. So here theta j power 1. So this is representing the L1 regularization. And if you apply the L2 regularization to the cost function, here lambda into summation of j equal to 1 to n cardinality of square. Okay, so here again j is representing the number of features available in the given data set. As we said, here we are having the one feature, so theta 0 and theta 1 has to be considered here to update the parameter value. So when you're applying the theta 0 and theta 1 with the regularization parameter 0.1 or 0.01, you see it will minimize the value. It will minimize the parameter value and added into the cost function. So by applying this lambda, we will get the model by avoiding the overfitting. That means it is learning the required feature. Unnecessary, it will not read the noisy features from the data set. Thanks for watching.